question number 5a and b, the transformation, there's already a transformation that's occurred on the f of x, and we want a further transformation. So we want to know what the change between the first expression and the second expression is. So the outside the changes are a little bit easier to track in that we can always just get the right shape and orientation and adjust the shift afterwards. So in this case here, if we know that going from this expression to this expression here, we need to expand by 3. So my new expression should be 3 times f of x. Now the problem is if we expand this by 3, I'm going to expand that by 3, and this is all my outside changes. The problem is this becomes minus 24. So then we just have to make sure we adjust for that horizontal, the vertical shift, by shifting it in the right position. So we're going to shift it up 17 to get it in the right spot. Okay, so the outside we can just match the leading coefficient, the coefficient of -3, and then adjust our shift on the outside, because there's not much going on the outside. But the inside is another matter. Now this one's not too hard, because if I take a look at what's happening on the inside, so I'm just going to focus on the inside here, I have a plus 3, so that's left 3 to left 1, so that must have gone right 1, and then that must be x minus 1 as my transformation. So I've probably got this right. Okay, now that's an easy one, so we want to have some more concise way of doing it. And so to do that, it is now important to be able to keep track of old x and new x, original x and the new x here. And I'll show you how that works. So we have to be able to explain the transformation and also write the function notation. So I'm going to do it like this. Basically this is, I'm just going to do it over here, my original x plus 3, and I need to make it into the x new plus 2. Well, the notation is when it's equal to the old x. That's my notation. My description is when it's equal to the new x. And so if I want to know what happened, I can just rearrange this expression. So my original x plus 3 equals xn plus 2, and then solve for the new x. And I can see that I ended up going to the right one. So that's my horizontal change. That's going to be horizontal shift plus 1. If I want to know what the function notation, the f of x is going to be, I need to have x minus 1. Well, I can just solve for my old x, because that gets me back to that's the function notation form. So if I just solve for the old x, I end up with x new minus 1. So that's my notation. That's what I put into my f of x in my answer. Okay, so this one wasn't too difficult, but the inside can be very difficult. So if we want to have a concise way of doing it, we can just keep track of our notational form and our actual transformation form by solving for the original x or the new x.